Here it comes, buddy. The path is getting shorter over here. All right, coming up. Oh, is it stuck? This might be the heaviest thing we've had on here. Where are you going? Alrighty, well, I just got to say that this thing is freaking massive and it weighs a metric ton, literally a metric ton. So this is 118 kilograms, which is basically 260 pounds. It's just, what's going on, everybody? I'm Average Joe and welcome to another Average video where we try to do average testing on basically anything battery related that we can get our grubby little hands on. So in today's video, we're going to be checking out and testing a 15 kilowatt hour lithium iron phosphate battery from Gobel Power. Alrighty, so a couple quick specs before we get started. Like I said, it is 15 kilowatt hour. It's got EVE cells in it, and I believe they're the 280Ks. I don't know if that's 2 or 3, I already forgot. It's got a 4 amp active balancer on it that has Bluetooth, so we can log in there, hopefully, and change some stuff, possibly. It weighs a freaking metric ton, and they've got like 4 or 5 different options for this specific battery. So there's a basic, a standard, and then there are 2 premiums. We got one of the premiums. I don't know which one. Let's find out. I guess we will start right up here on the front. So of course it says Gobel right here. Part number is GP SR1 PC200. Nominal voltage is 51.2 volts and they are 280 amp hour lithium iron phosphate batteries inside. Right over here we're going to have your on and off button for your BMS. We have a ground terminal, some really big, strong, heavy duty handles right here on the side because you are going to need it with this. And then obviously we have 2 positives and 2 negatives with M8 bolts inside. Right here we have a 250 amp circuit breaker. Let's see if it has a good ka-chunk or not. No, that ain't too bad. Yeah, that's not too bad at all. Right below that we have a push to trip button for our circuit breaker. Right here in the center is going to be our little tiny screen. This is basically going to give you some basic information about the battery, you know, battery voltage, cell voltage, etc. Right down here is going to be all of your communications and LED indicators. So we have an on and off indicator, run, alarm, and then your battery percent state of charge. There's actually 6 LEDs right there. We also get a reset button. And of course, we're going to get our dip switches right here for assigning each battery a number or location if you're basically paralleling a bunch of these together. Right next to that, we're going to get your dry contact switches and then your communication ports right here. So RS45A and CAN port is going to be for your inverter. RS232 is going to be for plugging into a computer so you can see the specifications of the BMS. And then finally the RS45B and C is going to be for paralleling 2 more batteries. Alright, we'll go ahead and turn it on real quick and we'll see the screen light up. So we hit menu to enter it. So you got your analog info. You can hit enter here. Pack voltage is 51.98 volts. All right, so we'll go down to cell voltage. We'll hit enter. So we're basically sitting 3248, 325, yeah, 325, 325, etc. So they're all obviously pretty much the same, but that's just because they've been sitting here for a while. Go down one more, cell capacity. So it is shipped at 37.57% state of charge. It looks like their last capacity test was 299.9 and the remaining amp hours right now is 112.7 amp hour. And they have done 1 test on this battery. All right, we'll back out of there. We'll go down to BMS status. We're sitting at idle, of course. We can go down to the record. All right, so we've had an under voltage protection. That is from their first test, and that's pretty much it. Okay, so just one of those. BMS status right now, where we shouldn't be in any sort of protection status, which we are not. Okay, so we'll back out of there. I think that's probably all we can. Oh, so you can change. Oh, look at that. You can change which protocol you want to use. Look at that. That's cool. So there is a whole bunch of stuff in here. So we'll probably be hooking up to the Lux Power a little bit later. Look at all these. There's actually quite a few in here. All right, cool. And we might even try a grow watt, possibly. Let's see what 485 says. It's probably all about the same, but who knows? There's actually quite a few in here to choose from. All right, cool. Go down to system settings, baud rate, etc. And that is pretty much it in here. If we turn it off to this side over here, we get a sticker with all the specifications. We get the premium model, like I said before, and then we also get a QR code right here. All right, so if we go over the sticker right here, it says Gobel Power Rechargeable Lithium-Ion Battery, even though it's not a lithium-ion battery. I think that's just part of how it's supposed to be packaged and shipped. Anyway, model number is GP-SR1-PC200, which we already said. Battery energy is 14.3 kilowatt hour. Nominal voltage 51.2 volts, capacity 280 amp hours. Maximum charge voltage is 58.4, max charge current is 140 amps. Max discharge current is 200 amps, and it looks like you can parallel up to 15 of these batteries. You cannot do a series connection, and it has a 4 amp balancer like we already mentioned, and the ingress protection is IP21, and then they got your temperature ranges right here. All right, so one thing that's nice about these batteries is they give you your own QR code that's related to your specific battery. We'll go ahead and scan the code right here. Boom, here we go. So basically it decodes your QR code. Anyway, we scroll down just a little bit and it's going to give you the specifications of your battery, which we already went over just a little bit. So of course they're lithium iron phosphate. We got the premium cells. BMS type is GP PC200. We have a 4 amp Bluetooth active balancer. This one does not have a heater, but it looks like you can get one. Our cell type is EVE LF 280Ks. Cell grade is HSEV. So there's a couple different ones. There's like a basic, a standard, and a premium. So that's where the cell grade kind of comes into play. Anyway, scroll down just a little bit more. We get the pack test results. So full capacity, 303 amp hours or 15.51 kilowatt hours. The max charge voltage that they were able to get to was 58 volts. And then the minimum was 43.18. All right, this is crazy. All right, and then of course they have their charge steps and discharge steps right here. All right, so basically what they did is they went to 55.5 and held it there for a while, and then after that they went up to 58 volts, and then basically whenever the first cell reached 3.65, they have gone through and matched the cells so good that they were able to charge it up to 58 volts. Which means that most cells are at that 3.6 volt range. Anyway, discharge test steps are discharging at a consistent current of 100 amps. Document the minimum discharge voltage when the voltage of a single cell reaches 2.5 volts. And that's where they were able to get down to 43.18. Oh, look at this. They even include some voltage curves here. All right, we scroll down just a little bit further and it looks like we have all the information for every single cell that they used in here. So 1 through 16, they put a battery cell ID on those, and then they also listed the QR code for every single cell, the capacity for every single cell. So they're all sitting at 314 amp hours. And then all the way over here is going to be the test date, which is January 9th, 2024. All the cell information right here, which is pretty badass. Alrighty, moving on is going to be bottom side. We have 4 lockable casters. I guess there's nothing too crazy special about those, but we do have casters. And honestly, it does roll around really, really good, which I'll show you here in just a little bit. I don't think there's anything on this side. No, there's not. And that is pretty much it. This did come with a bunch of different accessories and all of that kind of stuff. Battery terminal covers. They basically just slip right on and they cover up the entire the entire terminal basically. All right, so you can turn those in any direction that you want. You get 2 positives and 2 negatives. So we're going to get 2 little brackets right here, which we would basically, you know, if this is standing up, you're going to line these up right here, and then you can anchor it to the wall. So of course you get 1 for each side. You're going to get a nut and a bolt for those, so you can mount those right over here. You're going to put your nut and bolt in there, and then they give you a couple of anchors to mount to the wall, so that's kind of nice. Looks like they gave us a 50-watt pre-charge resistor. All right, next one is a RS-232 to USB cable right here, and then we also get the little terminal that goes in our dry contacts right there, which I'm just going to put it in there so I don't lose it. We also get an Ethernet cable right here. And then finally we get some big old honkin' battery cables. These are roughly, I don't know, a little over 3 feet long. And these are 1 AWG. These are the silicone brand, and they are rated for 200 degrees C. And of course they are nicely crimped. Nice. Alrighty, let's open it up and see what we got inside. Boom, there we go. So we have a thin layer of this phenolic type material. Boom. First impressions is fan-freaking-tastic, and everything in here is nice and tidy. All right, so starting up here in the front off of our battery terminals right up here, we got 2 wires going to the BMS, and then down there on the bottom we've got 2 wires going to our negative terminal right there. So it's got a bus bar going to the 2 terminals, right there, and then for the positive we have 1 large cable. I'll try to get the AWG size here in a second. Anyway, that goes into the 250 amp circuit breaker, and then it's going to exit out of the circuit breaker, go to the little tiny bus bar that connects the 2 positives right up here on the front. And then right behind the BMS we're going to have our active balancer right back there. And I did see a blue light on somewhere. There it is. So the active balancer is on basically all the time. And I also saw a red light on back there somewhere. There it is. Alrighty, so active balancer is going to be on all the time. And we all know how we feel about active balancers being on all the time. They shouldn't be on all the time. We're gonna have a couple circuit boards on that front panel, so that's gonna be the screen and the communication board and our BMS power button, or our on and off button right over there. And then right over here on the side they've got a QC list. Check appearance of weldings of the case, wheels installed, cells sorted and positioned, and so forth right through here. So they do have some sort of quality control happening, which is great. All right, looking from the top down, I would say everything looks to be fan-freaking-tastic. So we have positive here. It's going to snake around this way, go over to this side, and then snake back down to our negative right here. So the negative right here is going to be battery number 1, and they have their balance leads marked correctly. So B1, B2, etc., all the way down to battery 16, so all those are clearly marked. We have our bus bars attached to the cells by serrated flange nuts. We have our balance lead and our active balancer lead attached to a single screw in the middle of the bus bar, which I kind of prefer. Looks like we have 1, 2, 3, and 4 temperature sensors, silicone down to the cells. Typically you see them attached to this center brace, so that is nice that they're doing it to the cells. We also see each battery has the number attached to it, which is going to correspond with the test that they did earlier that I showed. Let's see what else. They have holes for the vents, so that's good. Everything is nicely routed and covered in the wire wrap. We have separation in between cells from each side and in between each cell right there, all the way around the outer edge. There's no cells touching each other. I guess everything in here is looking fan-freaking-tastic, except I am not seeing a little tiny paint or pen mark on every single bolt, signifying that it's been checked or torqued. So it would be nice to see that. I guess we could check these ones too. And one other thing that I just noticed when I lifted up the positive and negative terminals is I don't see any thread protrusion coming from the battery terminals. coming out of the serrated flange nuts right here. So I would like to see at least a thread coming out of there. That's basically coming from my aircraft background. Typically you want to see, you know, at least a thread or two coming out. That would be a suggestion for my part. I really don't know how they would get to that because it looks like they're using like a cutoff bus bar so they could attach their balance leads and stuff like that. I guess if you got rid of that, you would get your thread protrusion, but then I don't know how you would safely attach all of these terminals right here. So is that technically a con? I don't know, probably not. I guess as long as these are tight, which they are, it's gonna be just fine. All right, I was gonna try to get the size of these battery cables, but I can't unless I cut the sheathing off, which we could technically do. Of course, I'm not a fan of doing that. I think it's in that spot where it's not going to give me the size. Alrighty, I got the sheathing taken off, and this is like fiberglass sheathing, so if you're cutting this stuff, kind of be careful. This might be kind of like that fireproof rated stuff. That's what it feels like, at least. Anyway, I got the sheathing off, and I can't seem to find the AWG on the smaller size or for the bigger size. But what I can do for the bigger size is I can bring in the battery cables that came with it, and those are basically the same. So this is probably a 1 AWG wire right here, and these were probably, I don't know, these are probably 4 or bigger. So, but you got 2 of them, so that's nice. All right, so there you go for this right here. I think the next thing I'll do is I'll pull off one of these channel rails right here, and we'll see if we can get to one of the QR codes on the cell. All right, let's see if we can get underneath here. Ooh, there's a QR code. Boom, there's our QR code, and it doesn't look like we have anything else laser etched over the QR code, which is good. There's no A, B, C, or anything like that on it. So we'll scan that real quick and see what it says. Boom, there we go. So these are EVE power cells, 04Q. I'm not sure what that is. Lithium iron phosphate, of course. These are LF280Ks, 280 amp hour, 896 watt hours. Production date is 23/11/2023, so they're not very old cells at all. Production city is Jingmen. And the number of cells produced, at least in this batch, was 4,364 cells. Go ahead and put this back on. Next, we're going to take a look at the BMS software. So we're going to plug into the RS-232 port right over here. And then also on the computer right here, you can get all this software right from their website. So we're going to open up the BMS tools. All right, we're going to hit the open. So over here for pack information, pack voltage is 51.97. Our state of charge is 38%. State of health is 100%. Remaining capacity is basically 112 amp hours. Full capacity is 300 amp hours. Nice. Alrighty, right below that's going to be our cell voltage. So cell number 6 is our highest at 3225, and cell number 1 is our lowest at 3248, and our delta is 2 millivolts. But again, that's not really going to matter because we're not full charge, and this has been sitting here for... Alright, so from here, basically we're going to go over to parameter settings so we can see all of this. So we'll hit read. And I kind of want to make sure that this is kind of up to date, similar to Andy from Off Grid Garage. So right up here, the over voltage protection is set for 3.65. Charging, we got overcharge protection is set for 205. Discharge over current is set for 205. Pack over voltage is set for 58.4. Our balance threshold is set for 3.4. We kind of like to see 3.45, so I am going to change that to 3.45. And then right below that is our cell balance, or our delta. It's set for 30 millivolts. I wonder if I can change that, because I want to. I'm going to change it to 20. Just because I like that. Under voltage alarm is 2.6. Under voltage protection is set for 2.5, which is correct. Temperatures I'm just going to leave. Pack full charge voltage is set for 55.2. Pack under voltage protection is set for 40 volts. I guess we will see where that goes. Over temperature alarms, I'm going to leave that, and then the other temperature alarms and stuff, I'm going to leave all that. Enter right there. Now we'll go back to parameter settings, and then we will write those. All right, so those are all the parameter views on here. And another thing I wanted to mention is this does have the Bluetooth function, so we're going to connect with that real quick. So I downloaded their app. It's called EnerKey, and it's going to basically scan for any Bluetooth devices that I have here. So I need to go down to the fourth one down, which is basically just that number right there. We're going to connect to that. Boom, now we are connected. So up here on the top it says equalizing. I wonder if I can turn that off. I can turn it off. Nice. All right, we'll just leave it on for right now. We'll probably do a capacity test with it on and off and see if there's any difference at all. Anyway, right below that we have our total voltage of 52.021. It shows our min and max cell voltages, an average, and that shows our cell delta right there in the middle of 0.002 or 2 millivolts. And then it's got our system temperatures right there. Right below that, it shows all 16 cells right in here. Alrighty, so in here it looks like we can change quite a few things. So I guess if you wanted to change it to a different S, you could do that. Startup differential voltage, max equalization current. So this is a 4 amp like we said before. We can change that, it looks like. We have our stop and run voltages. We got our state of charge, our battery type, buzzer on and off. I just want to see what happens if we click on that. All right, so it looks like we can change a few things in here. I'm going to hit the alarm button. All right, so on this page, battery information, all the cells are showing normal. Acquisition line information, everything's showing normal. And then right below that is the temperature information. Let me click on the wheel up here. We could check for updates, language, we could change the name, and then change the password, I guess, if we needed to do that. All right, there you go. There's all the BMS information and the active balancer information and a few things that we can modify, which is pretty awesome, to be honest. The next thing I'm going to do real quick, which will probably take many, many hours, is recharge the battery.
Many hours.
Alrighty, it is the very next day. Time now is 11:01 a.m. and we finally got this battery fully charged up. So right now we're sitting at 57.827 volts. State of charge and state of health are at 100%. Remaining capacity is 308 amp hours, which would be freaking crazy to me. Anyway, cells down here, we got our max and min. So max is cell 15 at 3.623. The lowest one is cell 8 for 3.606. Our cell delta is 17 millivolts. All the cells down here are basically 3.6 and higher. The only alarm we have over here is a pack overvoltage. Next thing we're going to do is a capacity test. You guys remember the old grow watt, right? Just tuck that right in there. So I have the laptop hooked up to the RS-232 port. I have the BOOM shunt connected up right down here, and obviously we're connected up to the old 12K grow watt. So from the output of the inverter, we're going over to the 5K charge inverter right there, and we're gonna dump all the battery energy into the battery bank that's right over here. I think what we're gonna try to do is basically a 100 amp capacity test and see what it does. All right, so since the inverter's been on for just a couple of minutes, we have drawn a little bit of energy from the battery, but not too much at all. So our starting voltage is gonna be 54.79. So far we've consumed 0.3 amp hours. Okay, I'm going to turn the output switch on, which will send power to the EG4 charge inverter over here. And then as soon as that powers up, I'm going to flip the breaker and the test will begin. Hopefully. All right, there we go. Drawing 108 amps on the computer, 107 on the BOOM shunt. And then if we go down to the charge inverter, we're actually doing 88.2 amps. Nice. All right, well, I will let this go. It'll probably take around 3 hours, and I will be right back. Alrighty, so I think we're about halfway through. Yes, we are. So we're at remaining capacity is 150.7 amp hours left. Look down here on the BOOM shunt, still doing 108 amps or 5,571 watts. So we've consumed 154 amp hours on here. If we scroll over, we've discharged 8 kilowatt hour so far. All right, since we're here, I'll just do a couple temperature readings if you like, and if it's in view. We're sitting at 84 degrees right in the center of the battery. Go to one of the terminals, those are around 87 degrees Fahrenheit. All right, next thing I want to do real quick is I want to pull the cover off the top while we're still running. So we'll do that and we'll take some temperature readings in there. So right in the very, very center, we're sitting at 86 degrees Fahrenheit, and honestly, everything back there looks really, really good. All the hot stuff is going to be right down here. Hottest spot that's showing up in there is around 127 degrees, and that's going to be the BMS, it looks like. Yeah, so I don't know if you can see the red piece here moving around. That's just going to the automatic hotspot. So there we go. It looks like that heat sink right there is basically 128 degrees Fahrenheit. Go over here to the circuit breaker. The terminal right here is around 118 degrees Fahrenheit. The battery cables, this one is 103 degrees Fahrenheit. Ones down here on the front, those are around 110, which is just behind the terminals right here. That's the positive. And then the two small ones, 103.6. That is 112 on the negative side. I would say everything's looking pretty good in here. Not too hot. All right, time now is 2:42 p.m. and we're almost at the end of the first capacity test with the active balancer enabled or on. All right, so right now voltage over here says 48.3. We're still drawing 117.9 amps. State of charge is 6%, and it says we have a little over 19 amp hours left. Our cell differential, I just saw 175 there just a second ago, but that's kind of bouncing around between, we'll say 100 and 170 right there. We click on the history over here. So far we have discharged 14.5 kilowatt hour so far.
Moments later.
All right, so now we're starting to get some alarms. So we got a pack under voltage, cell under voltage, and our state of charge low. Consumed 14.8 kilowatt hour, 291 amp hours. Yeah, the inverter's getting ready to shut off. All right, inverter just shut off. So if we just go with this right here, I would say we did fan-freaking-tastic. So now our voltage is actually starting to come up a little bit. But over here, oh, cell under voltage protection. I just missed it. I wasn't even looking at that. So I'll have to review the video to see which cell actually did it. Damn, I wasn't paying attention. So we did reach a cell under voltage protection. Alrighty, just got the charger hooked back up and started charging, and I think what I'm gonna do this time around is charge it up without the active balancer. Boom, right there. And then we'll see what it is whenever it's fully charged. All right, so it is the very next day, and it is 4:50 p.m. It took a really long time to charge it. Anyway, we're sitting at 55.87 volts, 100% state of charge, state of health. It says we have 294.27 amp hours remaining, or that's our full capacity. And then if we look down here, we do have a couple of cells balancing. Again, this is without the active balancer. So our cell differential is 63 to 64 millivolts, which is, in my opinion, fan-freaking-tastic. So it just shut off with a pack over voltage and just basically a cell over voltage. So that's where we're sitting at right now. I might let this sit here and balance for, I don't know, 5-10 minutes, and then we're going to do the discharge test again without the active balancer. All right, so give me a couple of minutes while this balances out, and then we'll start the test. All right, it's a couple of minutes later, and we're basically at the same point as we were for the very first test. So 57.8 volts right over here, and our cell difference is 12 millivolts, which is actually a little bit better than the last test. I think it was around 17 or so millivolts. Either way, we're going to start the next capacity test. I've got the BOOM shunt connected right now as well. All right, so I'm going to go ahead and turn on the inverter. All right, inverter is booting up. We're drawing basically 3.5 amps right now. I'm gonna go ahead and turn the charge inverter on, and we're gonna repeat the same test without the active balancer. All right, here we go. All right, test actually started maybe just a couple of minutes ago, maybe 3 minutes ago, so 5:10, and we're at 52 volts. We're drawing 108.47 amps, which is around 5,500 watts or so. This test should take around 3 hours, so I will be back in a little bit.
A little longer than a few minutes later.
Okay, we're down at the bottom end. We're at 47 volts, drawing 120 amps. State of charge is at 0 on here, 2% left on the BOOM shunt. Our delta right now is 112 to 180 millivolts. So if we look at the BOOM shunt real quick, we've actually consumed 290 amp hours. We scroll over here and we're at 14.8 kilowatt hour. The inverter shows 45.5 volts, and pack over here voltage is 45, so it's pretty close this time around. All right, cell under voltage, state of charge, pack under voltage, and here it's about to go. Are we gonna, oh, look at that, we reached 15 kilowatt hour, 294 amp hours, nice. There it goes. We got it. All right, so on the BOOM shunt, we got 294 amp hours and 15 kilowatt hours. Alrighty, I have my cat here with me, and we're gonna start wrapping up this video because it's gone on quite a long time, and we've only managed to open it up, take a look inside, take a look at the BMS and the parameters and all that kind of fun stuff, and do 2 capacity tests at a little over 100 amps. And we actually got 15 kilowatt hour on that second one. And we also got really, really close to 15 kilowatt hour on the first one as well. Right, buddy? That's right. Hey, that's my microphone. Honestly, that is fan-freaking-tastic to me. All right, so like I said, I'm going to wrap up this video and we're gonna turn it into 2 videos. The next video, we are gonna hook it up to the Lux Power inverter over there, and we are gonna run some big loads on it. Basically, we're gonna hook it up to my house and run my entire house. Basically, what I wanna try to do is run it real close to the 200 amps that the BMS can handle. And I saw a little consistency actually in the settings and the sticker and all that kind of stuff. On the sticker it says 150 amp for charging, however in the BMS it shows 200 and a max current of like 205. So that's basically what I want to do in the next video. Is we want to run it really, really hard. We want to do 200 amps down and see how much we can go up. Alrighty, so far this battery's done fan-freaking-tastic, even though we really haven't done a whole lot to it yet. That's right. Yes, that's right. We haven't done too much to it quite yet. That'll be in the next video. Alrighty, well that's pretty much all I got at the moment. If anybody has any questions, comments, or concerns, or wants to see something specific with this battery in the next video, make sure you put those comments down below. And of course, if anybody's looking for a 15 kilowatt hour battery that weighs a metric ton, they're actually offering free shipping right now with a 5% discount. I'll put that up on the screen, and of course I'll have that link down below. Alrighty, well that's pretty much all I got until we test the crap out of it in video 2 with Horace's tail. Make sure you hit that smash button on your way out, and I'll see you on the next.